Seeing the manufacturing process of high-density insulated ropes, I finally realized that this rope is actually made from the plastic pellets in front of me. Its initial form is only slightly thicker than a few strands of hair, yet it can meet high standards for salt resistance, corrosion resistance, and waterproofing. The main material, PP polypropylene, is colorless, odorless, and insoluble. Open packaging to let materials flow into the tank. Inside, there are two types of materials, PE and PP. Then, fillers and plasticizers are added, and the mixture goes to the plastic molding machine to start softening the pellets. The working principle of the molding machine is to complete the decomposition through heating, and then extrude it out from the other end. But at this point, it still feels very hot to the touch, so it needs to go through a rapid cooling process. Then we move on to the second step, where the stretching rollers continuously pull the plastic strip forward into the thermoforming dryer. Inside the chamber, it will undergo continuous heating and softening, meaning it is heated while being pulled outward. This way, the diameter of the plastic strip can be reduced several times, and its length will also increase several times. At this point, the diameter is not much different from that of a pencil lead. Next, the yarn is transported further, and begins to be wound using a hand wheel. Below, there are more than 20 types of apples, and each yarn must be wound around the corresponding door frame. I have to say, the automation program in the facility is indeed advanced. You can hardly see any manual functions, as everything is completed almost entirely by a mechanical assembly line. Then we move on to the third step, the so-called crowning, which is to use the rotating motion of the equipment to twist the three fine sand threads together in the shape of a twist, from one end to the other end. The advantage of this design is that it increases strength, just like a wire rope, which is made by twisting many strands into one strand, and then twisting these strands into one strand. As the rolling is completed, the first type of splitting begins. There are 8 coils here, with 7 thin wires on the outside and a thick wire in the middle. The 3 strands that have just formed are twisted into one, and during this process, the rope must remain taut. Only by doing this can the ropes intertwine tightly. If it becomes too loose, it will weaken the strength. Open the protective door and quickly remove the rope while it's still hot. Although this rope used up 1,115 fine sand lines. It looks amazing, but compared to the second type of PP rope, it is nothing. The yarn used in the giant rope is very different from the previous round in terms of production process. This equipment is divided into 3 steps. It wraps the outer circle in a spiral manner, just like a nesting doll, which is a circle inside a circle. The first round uses the least material because it is the thinnest. As the diameter increases, the number of sand lines should gradually increase. At this point, you can see a fairly smooth insulated line. But do you think that's it? Not even close. The best part is still to come. On this side, the equipment keeps rotating, wrapping the previously formed PE line with 2 others, increasing the strength to more than 3 times. This simple rope is actually made up of thousands of fine sand lines. So do you know how the strength is made in a larger circle? It all depends on this heavy-duty equipment in front of us. Take a close look. This strand is equivalent to what we just saw, meaning it twists together with the previous 3 strands. The strength has increased by more than 3 times again. Some might wonder why such a large machine is needed. It's because this rope is too thick for smaller machines to twist tightly. In the blink of an eye, the insulated ropes are formed in small, medium, and large sizes. But here's a little question for you. Can you guess why there's an orange line among the white ropes? What role does this orange line play?